So for inverse circular functions, so all of these 6 questions are inverse entities will get inverse circular functions. I'm not sure what method you use, how many formulas you remember, but like think about when we learned differentiation in chapter 6. I ask you to just remember one formula, like there are three, like the easiest one, like sine inverse x, and there was another one, sine inverse x over a, and there was a sine inverse gx one, and I ask you to remember the sine gx, sine inverse gx. If I want to diff that one, you will have g dash x over square root 1 minus gx squared. Okay, this is the rule I ask you to remember, and for antidiff, I will use this to go backwards as well. I don't want you to remember any other rules more than that. So for each formula, just remember the most complex one, and if you work backwards from that, you get answer easily. So the antidiff of cos inverse of gx is negative g dash x over square root 1 minus gx squared. And say, so therefore, if you antidiff like something, you can either get sine inverse or negative cos inverse. And you can either get sine inverse or negative cos inverse. So therefore, we only think about the positive one. So we only think about the sine inverse. So you get exactly the same thing. I want you to think about this question. If you have antidiff 1 over square root 1 minus x squared. Okay, what's the antidiff of that? Sine. So it can be sine inverse x, right? Can I also say that's a negative cos inverse x? Yes, and then I need to plus c and plus c, right? Well, I'll say plus d for this one. Why I can have two different graphs? Like, let's think about what sine inverse x looks like. Sine inverse x looks like that. Okay, that's the sine inverse x. And negative cos inverse x. So cos inverse x looks like this. And negative of cos inverse x is here. Okay, so that's negative cos inverse x. And that's sine inverse x. And obviously, that's two different graphs. But why antidiff the same equation, I can get two different answers? Same, yeah, what else? I'll draw just better. So they have the same, you can say they have the same gradient, or say this one move up by pi onto unit, you should have the left-hand side graph. And that's the difference between the C and D values. Yeah, that's the difference between the C and D values. That's why antidiff the same equation, you can have two possible answers. One is sine inverse x, and the other one is negative cos inverse x. If you sketch them separately, you should have like those two graphs. But like the right-hand side move up by pound to unit, you should have the left-hand side one, and that's exactly the same. So that's why you have the constant C and D. So when you use sine inverse x, the C will be different from the D value if you stop pointing like for C and D. So if you change the C and D value, you will end up with the same graph. Say if C equals to 0 and D equals to pi 2, then those two graphs will be identical, and then you will have the same fx function by changing the constant. Okay, so that's why we can have sine inverse and negative cos inverse for the same function. All right, come back to this. How we can use this one? I want to remember for log. When I want to antidiff log, I'm trying to make the function becomes g dash x over gx. That's like if I say, okay, this kind of a log function, so I will try my best to make the equation becomes g dash x over gx. Therefore, this question is the same. You will try to, if you realize this is the antidiff is a sine inverse or tan inverse function, you will try your best to make it into this form. Okay, you try your best to make it into this form. Okay, so this is the sine inverse one, and if I write the tan inverse, I'll show you an example what to do with that. So tan inverse gx is g dash x over 1 plus gx squared. So antidiff of that, you will have tangent inverse gx. Okay, so first of all, you should realize there's a inverse circular function antidiff, and then you're trying to make the form into those two different forms. So, okay, examples. I know some of you can remember more formulas and directly give answers for the first one, but now I'm just want to use a simple question to start with, and then to give to show this method. First of all, if you see a square root, and the square root is a quadratic, okay, 90% of the chance is a sine inverse function. Okay, it's a sine inverse function. So if there's a square root under that, and it's a quadratic inside the square root, that's kind of a sine inverse function. So what form I want to give? I want to give g dash x over square root 1 minus gx squared. Okay, this is the form I want to give. I think some of you may think it's very hard, but like when there are complex questions, this is the best method to solve. Okay, so where to start with? I want to start with this 1. Okay, I need a 1 there. Okay, I need a 1 there. So what I will do for this question is like I want to antidiff that. So this is the same as antidiff 1 over. Okay, think about that. I'll just go step by step. If I want 1, I need 25 out because I need to take a common factor 25 out, and that's x squared over 25. Okay, yeah. So I take I want a 1, so how I can get a 1? So I need to take this 25 out. Okay, so after I take this 25 out of the square root, I will have like this 105 here. Okay, inside is 1 minus x squared over 25. I need a gx squared form. So overall, I need to put it to gx. Okay, gx bracket squared. So in this case, my gx is x over 5. Okay, after I make it into 1 minus something squared, the something is gx. So I have my gx is x over 5. So what's g dash x equals to? 105. Okay, so my top, like this top, should be 105. And the good thing is I can just put this 105 up here. Okay, so I don't really need to make any value. This 105 is just good to put it there. I'll show you if there's no 105, like I need to create one what to do for the next question. But like that, I'll just put 105 here, and that's 1 minus x over 5 squared. Yeah. So now it's exactly in the form of g dash x over 1 square root 1 minus gx squared. And I know that's the sine inverse of x over 5. And plus c. Okay, that's how I know I'm not doing the quickest way for this question, but like I want to use this example to show you how to work on those type of questions. Okay, so the key idea is I need a 1 here. Okay, I need this 1 here. So to make that 1, I need to take the constant as a common factor first. And then I want to think about what is gx. Okay, and if I figure out what is gx, I will think about what's the g dash x on top. And do I have that constant? Is there someone in my class? No? No? Okay. Alright, like I'll show you another example. Okay, I'll show you another example. Let's have a look at the second one. Okay. Second one. key thing is I want to get a 1 for the constant. Therefore, guys, yeah, that's what we'll have. Okay, so 3 over, take the 25 out, and what I'll have is 3 over 5. After I take the 25 from the square root, I have 3 over 5, and then times 1 over square root of 1 minus. Okay, the whole thing needs to become gx squared. I will have 2 on 5x squared. Okay, so make 1 first and then make gx squared next. Okay, so now I know my gx equals to 2 on 5. So what my g dash x must be? 2 on 5x. 2 on 5. So therefore, I will change this top to 2 on 5. But I just can't times something on top of it. I need to times 5 on 2 on it as well. Okay, to times 5 on 2 on it, because I can't just times on 5. I need to also times 5 on 2 to make it back to 1. Therefore, just rewrite this. I will have 3 over 2 in the front times 2 on 5 over square root 1 minus 2 on 5x squared dx. So I know that 3 on 2 is a constant, and then that's sine inverse 2 on 5x plus c. Okay, the key idea here is I just want to use one formula to solve all the antidifs, and then I need the 1 minus the gx squared. After I figure out gx squared, it's a linear, it must be a linear, and then I will figure out what I need on the numerator. So if I put something on the numerator, I need to divide that as well, because you just can't put a number on top of the fraction. So you need to divide that to make it back to 1. Okay, so that's the idea to solve for this question here. Okay, that's the sign. Well, you can make that becomes negative cos inverse as well, so it's exactly the same, but you can make it negative cos inverse. But it's not necessary. I will just say make it stay as sine inverse. Tan inverse. Okay, tan inverse. So if you have some like quadratic under the denominator, 90% of the chance it will be the it must be a plus. Okay, first of all, it must be a plus. If that's a minus, it's not going to be tan inverse. So if you have ax squared plus c on the denominator, it will be tan inverse. Okay, that will be tan inverse. So again, tan inverse, I need g dash x over 1 plus gx squared. Okay, so that's the form I need to do the antidiff. So if I go in antidiff of that, okay, first of all, I have the 3 on 22, 32 up first because I need this 1. Okay, I need that 1. So times with 1 over. So if I take 32 as a common factor, that's 1 plus 6 over 32 x squared. Okay, so the first thing is take the 32 on the denominator as common factor to make the 1 out. So the constant, take the constant out, 32, and then you have 6 on 32. What's 6 on 32? That's 3 on 16. Okay, also I need the gx square form. So we have 1 over 1 plus, okay, 3 on 64. So that's square root 3 on 4x, and then whole thing squared dx. So it's 1 plus, that's the gx. So gx equals to root 3 on 4. What's g dash x? So I have figured out what's the gx, so what's g dash x? Root 3 over 4, right? So I put the root 3 over 4 here. So I must times 4 on root 3 as well to make it balance, like become 1. And then I can simplify here. That's 1, that's 8. And root 3 and then 3 becomes root 3. So what I have here is root 3 on 8, 10 inverse of root 3 on 4x plus c. Okay, the steps is the same, or let's say it's even easier compared to the sign inverse one. Okay, because you don't have the square root, you just can directly take the 32 out as a common factor and make it 1 plus something squared. Any questions so far? No. Okay, I will leave D for you to do it, and I'll show you E and F, which is more complex. And these one are the basic ones. Okay, so it's already given a good form. But for E, okay, first of all, E is a quadratic again, but I don't have, it's not in a good form. So what we need to try is to complete square first, because I need 1 plus gx squared. So I need to complete square to see what could happen first. So I'll just quickly complete the square. That's x plus 3 squared. I need to minus what? I need to minus 9, so it's a plus 2. And then I can take the 2 out, because I need 1 plus the gx squared. Okay, so that's what I have. So what I can make further is that's 3 over 2 times. I need the gx squared. So that's not in the whole thing squared form. So I will go 1 plus x plus 3. Sorry, that's x plus 3 over square root 2 squared. Okay, I need to put the 2 into the square form. Okay, I put the 2 into the square form. So in this case, I know this is my gx. So what's my g dash x? 1 over root 2. So I will have 1 over root 2 here. So I need to times root 2 over 1 to make it balance. Okay, so, well, the gx is 1 on root 2x plus 3 on root 2. If you can't see it, I can expand it in this way. So the g dash x is the constant 1 on root 2. So I times root 2 on 1 in the front as well. So just rearrange it. That's 3 over root 2 times 1 on root 2 over 1 plus x plus 3 over root 2 squared. So the antiderivative of that should give you 3 on root 2, 10 inverse x plus 3 over root 2 plus c. Okay, so it's the 10 inverse gx. So step is the same, but take one extra step to do is you need to complete the square first and then figure out the constant by yourself. take the constant as common factor. In this case, it's 2. So take 2 out, and you get the 1 again. So it's 1 plus gx squared, and the number is not nice. So you need to figure out that by yourself. Well, I think when you look at me doing this question is pretty easy because I have to do that a lot of times. So I know what exactly should be done. But when you do it, I think it takes you a bit longer time because you need to figure out how to put a constant into the square and what's the derivative and what needs to be times to make it back to 1. So like all of this, you need to think by yourself, and it takes a bit longer than what you see I'm doing here. Um, okay, let's think about the next one. Next one, what's a half? The half gives you the square root. Okay, it's the square root. Well, I'll rearrange the order. Okay, remember when you see the denominator is square root and a quadratic in it, you will think about sine inverse. Not 100% of the time it will be like sine inverse. Or say like when you see something in that form, you will think about tan inverse. Maybe not correct, but you can try. Worth to try. When you can see it's not the tan inverse, okay, I'll let you know when you can see it's not the tan inverse. When you complete the square, if the sign is a minus, it's not going to be a tan inverse. Because tan inverse requires 1 plus gx squared. So if you have a minus here, it's not going to be 1 plus gx squared. It becomes minus 1. Like, it doesn't work. So this sign must be a positive sign, then it will work. So same as this one, okay, same as this one. You will think, okay, it's very likely to be like a sine inverse. So I will try to make it become 1 minus gx form, but I'm not 100% sure. I will just try it. So complete square is necessary first. So to complete square in this question, I need to take the negative 3 out. So what I have is x squared plus 2x. Well, what else I need to do is plus 1 minus 1. And then I'll keep the plus 15 outside. Okay, so it's 2 over square root of minus 3. And then inside the bracket is, okay, there's another bracket. Inside the bracket is x plus 1 squared minus 1. Bracket plus 15. Okay, these ones becomes x plus 1 squared. And you have the minus 1. Minus 1 is to go to times with the minus 3 as well. Is 2. So it's 2 over square root. Okay, expand the bracket. Plus 3 plus 15, so it's a plus 18. Okay, the constant is 18. So if you move 18 to the front, it's 18 minus 3x plus 1 squared, which is possible to make it into 1 minus 3x squared form. So what I'll do here is take the 18 out. It becomes 1 minus x plus 1 squared over 6. We're going to take the 18 out. You have 1 minus x plus 1 squared over 6 because 3 divided by 18 is 1 on 6. So what else we have is 3 over root 18 is 3 on 3 root 2. So that's 9 times 2 is 18. And then we have here the denominator is 1 square root of 1 minus x plus 1 on root 6 squared. So what we have here is this is the gx. No, I need to think what I want to be on top. So gx is that. So what's g dash x? So that's why I leave it empty. So what's g dash x? 1 on root 6. I can't just times 1 on root 6. I need to times root 6 on 1 as well. So I'll just make some space. So I will times root 6 on 1 here. Okay. So overall, what we have is this root 2 and this root 6 becomes root 3. So that's a 2 root 3 over 3 times 1 on root 6 over 1 minus x plus 1 on root 6 squared. Yeah, until here I have the correct form I want to make the antiderivative. So antidiff of that gives you 2 root 3 over 3 sine inverse, because you have the square root here. So you have the sine inverse of x plus 1 on root 6 plus c. Okay, even though it's very complex for this one, but I still use the same formula. Like I just keep using the same formula. Doesn't matter if it's complex questions or simple questions. Okay, you use the same way to do it. Okay. Well, if you get all of these, you can try d by yourself. It's not a hard one. Like it's just with substitutions. You can work out d by yourself. I think it's B. Like it's the inverse. I don't have the working schedule, but that's the inverse circle function. The second one is B. Do you have any questions? If no, you can just work on the exercise.